This problem gives us a system of 3 boxes and a pulling force, and we're asked to find the acceleration of the whole system and the tensions in the 2 ropes A and B. Let's start by drawing 4 free body diagrams, one for each of the boxes individually, and then a 4th one for the system as a whole. Focusing first on box 1, we see there are 4 forces acting on it. Its weight is straight down. There's a normal force straight up. There is the pulling force, capital P, to the right. That's 190 newtons. And rope A acts on it with a tension T sub A to the left. Focusing now on mass 2, there's the weight and the normal force. And there are 2 ropes pulling on mass 2. Rope A pulls to the right, and rope B pulls to the left. So there are 2 tensions there. Now looking at mass 3, there's the weight and the normal force. There's only 1 rope pulling on mass 3. It's rope B, and it pulls it to the right. Now considering all 3 boxes as a system, I'll draw this dotted line here. The forces acting on it are its weight, all 3 masses together times G, the normal forces, 1, 2, and 3, and the pulling force P is the only sideways external force. Now we can apply Newton's second law. Adding up all the forces in a certain direction gives you mass times acceleration in that direction. We'll do this for the x direction, and first apply this equation to the system free body diagram. The sum of the forces on the left-hand side comes from the free body diagram. There's only one, it's the pulling force P. And on the right, the mass is the mass of what we drew the free body diagram of, the system. That's the sum of the masses, times A. Solve this for the acceleration A. It equals the pulling force divided by the sum of the masses, which is 60 kilograms. And this works out to 3.17 meters per second squared. Part B asks us to find the tensions in the 2 ropes, A and B. So we'll write down Newton's second law again, adding all the forces in the x direction is mass times acceleration in that direction. We can apply this equation to any of the free body diagrams we want. If we try to find the tension in rope A, then we need to use a free body diagram where that tension appears. And that's either for mass 1 or mass 2. Mass 1 is easier because there's only one unknown in the horizontal. That's the tension we're looking for. So let's choose that one. Adding the forces along x from free body diagram mass 1, we get pulling force P to the right minus the tension in rope A equals the mass times acceleration. That's mass 1 times the acceleration. We can solve for the tension in rope A. Substitute numbers to find it equals 158 newtons. Now we write Newton's second law again and apply it to one of the free body diagrams, allowing us to find tension in rope B. Again, we have 2 choices. We can use mass 2 or mass 3. Mass 3 is simpler because there's only one horizontal force there, so we'll choose it. Adding all the forces along x just gives us tension in rope B, so that equals the mass, 3 in this case, times the same acceleration. Everything's accelerating together. When you calculate that, you find that tension in rope B is 95.1 newtons.